Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Using Sampling to Predict. All right, follow along. We can use results from a sample to make predictions about the population. Now, the key to success is as follows. You must understand what is out of what. And you're like, what do you mean by that? You must understand what the total amount of the sample is and what the total amount of the population is. You'll see what I mean when we start doing some examples. If the problem involves percent, then don't forget about the percent equation. The percent equation is the part equals the percent in decimal form times the base. And the base is another word for the total. But make sure you're using the correct total that the part is actually out of, because there could be two totals. There's a total amount for the sample, and there's also a total amount for the population. So please realize there's going to be more than one total. For example, problem number 1. To test computer chips, the manufacturer checks every 18th chip for defects. He found that 27 out of 450 chips were defective. If a total of 8,100 chips are produced, how many should he expect to be defective? Okay, get your pencils ready. The first thing we should check out is the sampling method unbiased, which would be a good thing. That means we can make valid conclusions. Or is it biased? Well, he checked every 18th chip for defects. That is an unbiased sampling technique. Now, how do I know that it is unbiased? You know what? I should have changed the way this question was worded. Is the sample unbiased? You know what? Let's change this right now. We should have said, yes, the sample is unbiased. Okay. Why? Because it is a systematic random sample. Go ahead and fill those blanks in. Okay. Second, if it is unbiased, then let's do the math. Now, pay attention to what was out of what. The 27 is not out of the total of 8,100. The 27 was out of 450 chips. We're trying to find out how many are going to be defective if there's a total of 8,100 chips. So that's going to be a lot more than 27 defective chips. So here's what we can do. We can take the ratio of 27 out of 450, and we can set that up as a fraction. Go ahead and write this down with me. And then we can multiply that ratio to the new total, to the total of the population that we were talking about, 8,100 chips that are being produced. If this work looks familiar to you, we actually did work like this with the probability module or chapter in the book. So this is very similar to work to what we've done before. All right, go ahead and use the fraction key in your calculator, or you could even use a non-fraction key calculator and take 27 divided by 450, and then take that answer times 8,100, and you should get 486 defective chips. Go ahead and write that down. Okay. The customers in a music store one morning are surveyed to determine their favorite activity in their free time. The results are shown in the graph. The person conducting the survey concludes that out of the 75,000 people living in the town that the music store is located in, about 64,000 of them either play music or listen to music in their free time. Is this a valid conclusion? Okay. You might recall that I taught you on the previous packet of guided notes called Using a Sample to Represent a Population, that on those guided notes I talked about valid conclusions should come from unbiased samples. How did the person doing this survey get their sample? They asked the customers in a music store one morning. Well, what is the population supposed to be? It's supposed to be the 75,000 people living in the town. Are you noticing what I'm noticing? There's an issue with this. Do all the people living in the town go to this music store? I mean, some of them might buy their music online. Some of them might not even care about music and therefore would never go online music shopping or even go to the music store. So there's an issue with this. This is actually a convenience sample. It's convenient to do the survey only at one place and only in one specific time in the morning. But that's not going to necessarily represent the general population of this town. So let's fill in these blanks. The preferences of customers in a music store might not accurately represent the preferences of the town's general population. Fill in those blanks. Now, we could check the math, but since the sampling technique was biased, then the conclusion is not valid. It's not. So I'll check the math anyway. The conclusion was playing music or listening to music in their free time. Listening to music was 45%, playing music was 40%, and if we add those together, that would give us 85%, which is 0.85, and if I multiply that times the total people in the town, I hope you're writing this down with me, that would give me 63,750, and that is really close to 64,500, or 64,000, about 64,000. Yes, this is about 64,000. But again, I'm not going to say the answer is yes, even though the math checks out. Since it was a convenience sample, which is a biased sampling technique, we're still going to say no. Oh, by the way, there's another way you could have done your math. You can feel free to write this down. If I take 64,000 from the original conclusion that this person made, and I divide it by the total, that would give me 0.853333, which is 85.3 repeating percent. Is that matching up with the pie graph? Well, yes, it is, because that'd be 85% for the two categories of listening to music or playing music. But again, it doesn't matter. I wish the math mattered, but since the sampling technique was no good, convenience sample, we have to say no. All right, moving on. Problem number 3. A store sells, that's right, I'm going to do this problem with you as well. This one's a little bit different. A store sells 3 types of pants: jeans, capris, and athletic pants. The store employees randomly survey every 10th customer about their preferred type of pants. A total of 50 customers are surveyed. And by the way, if you would add up this middle column, 25 plus 9 is 36. 36 plus 14 is 50. So yeah, 50 customers were definitely surveyed. Their results are shown in the table. If a total of 1,500 pairs of pants are expected to be sold next month, how much profit should the store expect to make on athletic pants in that month? So what are we given? We're given a table of values. These are the results of the 50 customers that were surveyed. But they're saying a new total, the total of the population, is 15,000. Or sorry, not 15,000, 1,500, 1,500. And what are we asked to find? We are asked to find how much profit the store would expect to make, because we're talking about next month. So we don't really know yet. But based on these results, how much profit should the store expect to make on athletic pants? So this is the part of the table that we care about based on what the problem wants me to find. Are you ready? We're going to have to do our work kind of in 2 parts. We first need to realize the 14 is not out of 1,500. The 14 is out of 50. So write that down. That's the fraction we're going to start with, kind of like we did on problem number 1. We did a very similar math here. We're going to multiply it times the new total of the population, 1,500 pairs of pants. Write this down. Calculator time. If you don't have a fraction key in your calculator, you could take 14 divided by 50 if you want, and you would get the decimal. And then take that times 1,500, and you should get 420. Now, that's not dollars yet. That's not dollars of profit. I didn't use the $825 of profit yet. The 420 is just the number of athletic pants that they should expect to sell next month out of 1,500 total pairs of pants. We still need to multiply this by what the profit is per item sold. 420 athletic pants we expect to be sold. Take that times the profit per item. So that's $8.25 per item. We're going to take that times the 420 athletic pants. And that will give you, calculator time, that will give you, boom, $3,465 in profit from just the athletic pants. Okay, now that I have done 3 different problems with you, I think you should be able to do the rest of these guided notes pretty much on your own. If you're given a table of values, it would be very smart to know what that total is going to be. Spoiler alert. Sometimes it's given to you. Like problem number 3, they told me that if I added these numbers together, I would get 50. Well, they didn't directly say add them together, but they already told me that there was 50 total surveyed. So sometimes it'll give you that number. Other times it will not, and you will have to figure that out. Remember, if the problem asks you about the conclusion being valid or not, 2 things must be true. Number 1, it has to be an unbiased sampling technique. Convenience was actually biased. And also the math has to check out. Now, problem number 2, the math checked out, but the sample was no good. That's why we said no, it was not a valid conclusion. For it to be valid, both things have to check out, the sampling technique and the math. All right, so hit pause on the video, do 4, 5, 6, 7, 8, and 9. I know that's a lot of problems. If you want to just do 4 and 5 first, or maybe 4, 5, and 6 first, and then save the last page afterwards, that's fine with me. That actually would not be that bad of an idea. So at least do 4 and 5. Hit pause, do 4 and 5, and then hit play to make sure you got 4 and 5 right, and then you can do the rest of the problems afterwards. Okay, so hit pause, at least do the next 2 problems. If you want to do all the rest, you may. Okay, have you already done at least 4 and 5? First things first, if I add these numbers in the table, I get 52 people that were actually part of the survey. Now, the problem is saying if they order 600 boxes, how many should be caramel? Well, the answer is not 13. That 13 is out of 52. So I'm going to take that fraction and multiply times the new total of 600 total boxes. And that should give you 150 caramel boxes, or boxes that would be caramel. If I went too fast, feel free to rewind. Feel free to hit pause after you rewound if you need to fix your work. Problem number 5. This was talking about the superintendent of the school district. He wants to know, how often do you volunteer? And the problem says, if the district has 2,000 teenage students, about how many positions should the superintendent have available for students? And here's the key part: who volunteer once a week. That is only part of the table. It's right here. Oh, that didn't highlight at all. Let me go ahead and switch to a pen. I'll choose blue. Boom. This section right here is the once a week section. These are the people from the survey that he used, and 29% of them said they would be willing to volunteer once a week. So let's take 29% in decimal form, which is 0.29, and multiply it times the new total that the school district actually has. It's not a new total, but it's their grand total of teenage students. So that is 2,000 students. And if you go ahead and multiply this, you will get 580. So that is our answer. That is what the superintendent should expect to be available to volunteer once a week. Okay. If you have not done number 6, then I would hit pause and do that problem. Maybe also do 7, 8, and 9 as well. If you only want to do 6, because there is money involved in this problem, fine. I guess you could just do number 6. So hit pause if you need to, and then hit play once you're ready to see how you did. Okay, so the manufacturer is sampling every 200th tablet computer. So that is a systematic random sample. We like that. He found that, or he or she found that it's 1 out of 50 that were defective, and it's $170 to repair. They're going to do a batch of 200,000 computers. So we can take our ratio, 1 out of 50, and multiply that times 200,000. By the way, if the numerator is 1, then you could just take this 200,000 and divide by the denominator, either way, and that's going to give you 4,000 computers. That could be defective. That's not a great number. We're not done. How much money can the company expect to pay in repairs? Let me go ahead and highlight. This is the key. How much money to pay for repairs? So we know it's $170 for just each computer, for one computer. So we're going to take this number of 4,000 defective computers and multiply it by $107, and that's going to give us $428,000 in repairs. Yikes! Okay, now I'm going to finally say it. If you haven't finished the rest of these problems on your own, you really should hit pause and do 7, 8, and 9 on your own, and then hit play once you're ready to see how you did. Okay, have you already done 7, 8, sorry, I went the wrong way, 7, 8, and 9? If not, you better hit pause now, because you have to be doing problems on your own, not just copying down work that the video shows you. All right, every 20th customer at the store is asked about their milk preference. That is a systematic random sample. So, for the question, is this a valid conclusion? The first thing I should always check, is the sampling technique correct? Or meaning, is it unbiased? Yes, this checks out. Every 20th customer at the store, and this is only for the store, so this is not like a convenience sample. We are trying to represent the store, only the store, so it's fine that it was at the store. All right, if you add these numbers in the table, you will get 240. Now, the store manager concluded about 40% should be low fat. Here's one way of doing your work. You could take 40% of decimal form and multiply it by the 240. Will that give you something close to 92? Now, it was 96. Should we say it's not valid? Keyword, about 40%. So exactly 40% is 96 low fat. It's 92 low fat, so that's pretty close. So saying about 40%, yeah, that checks out. So the sampling technique was good, and the math checked out. We're going to say yes. Now, if you're like Mr. Underkoffler, I didn't do my work that way. Well, maybe you did this instead. Maybe you took the 92 and divided it by 240, hitting the division key in your calculator, giving you 0.383 repeating, which is 38.3 repeating percent. And yes, that is what I would call about 40%. So either way you do your math, and maybe there's another way of doing the math that I don't even have here, but still shows that the conclusion of about 40% checks out. If you have a different way of doing it, that is fine with me. But the answer is yes, because 1, the system is a systematic random sample, which is good, and 2, the math checks out. All right, problem number 8. This was a little tricky because they gave you 2 totals. The 400 are just the survey, but we want to know how many kids in that area would you predict to drink 2 cans of soda or less per day out of 38,000. So I hope that you did not accidentally use 400 for your base, for your total, because we need to know how many kids out of 38,000 kids in the local area. See, it literally says how many kids in that area, not just how many kids who did the survey, but how many kids in that area. So words matter. Okay, speaking of words mattering, it says 2 cans or less. So we not only need this, we need this and this, because all of those would count as 2 or less. 0 is less. 1 or less is less. You're like, why does this say 1 or less? Maybe somebody's drinking a half of a can of soda, a partial can of soda. which could be possible. Okay, so if I take those numbers and I add them together, I will get 71%. Take 0.71 times the total kids in the local area, not times the 400. If you took it times the 400, hey, use your eraser, learn from your mistakes. And that's going to give you 26,980 kids. If you want to say about 27,000 kids, that's fine because we're making a prediction. It's kind of a little weird to say 26,980. So if you want to say about 27,000, that is fine with me. And finally, number 9 has a part A and a part B. Every 10th person is surveyed. That's a systematic random sample. We like that. 140. Did you realize that they gave a number in words? 140 is 140. Yeah, I know that was a little sneaky of this problem to do. But they didn't do it with the 800. Why? I don't know. All right, so 140 out of 800, that's our ratio, said, yeah, they'll buy a t-shirt. So how many people will we expect to buy a t-shirt at the next concert if 7,000 people attend? So based on those previous results, you can multiply it times 7,000. You can reduce this fraction if you want, or you can divide and get a decimal. That's going to give you 1,225 people buying a t-shirt. And then part B. So we already did part A. Part B, if $7.75 profit is made on each t-shirt sold, how much profit could be earned at a concert that 7,000 people attend? Okay, well, we already got the number of people out of 7,000 that would buy a t-shirt, so we can start with that number and multiply it times the profit. And that's going to give you $9,493.75 of profit. And that concludes the guided notes called Using Sampling to Predict. Thank you for watching. We'll see you next time.